much. I will try to briefly pass through my presentation. So the main motivation, so I would like to show you that SDN is not so secure as it very often we are thinking about. So if we look at the security issues, so the main problems is confidentiality, integrity, availability, and from the network control security, it's mean first of all to follow the requirements of AAA, so authentication, authorization, accounting, forwarding policy control, and access control. Well, so if you look at the traditional network, we'll see no separation between data plane and contra plane, so we have a lot of problems when someone tried to attack from the data plane to contra plane. So, because we don't have the centralized network vision, so because of that, we use we need some time for convergence of the router vision, and because of that we can use the different routers and have a different vision of the network at the same time. So next, layer by layer header analysis. Follow the traditional network. We cannot analyze the all layer headers in a package. Because of that, we have a very narrow vision during the analysis. All we have to spend a lot of time in order to collect the headers of the different layer. And again, access control degradation, it's a main trend in traditional networking because of the mobility increasing, I mean mobile equipments. If we look at the software-defined network, so the picture is so beautiful. So we have a split control plane and data plane. No way to attack control plane from the data plane. It's just iron door. So we have a centralized vision of the whole network every time. It's perfect. Control and manage traffic flows. So we even can predict what kind of application initiate and what kind of flow. We have integrity of different type policies, and we can analyze and control this integrity from the physical infrastructure up to the application layer. We have cross-layer header analysis, so because we extract the headers of all layers at the beginning of the flow, we can analyze the all header. And again, virtualization and mobility, especially I would like to underline virtualization, because virtualization would be very important for security. Later on I will show this. So, in SDN we have a, so I have to make some remark saying SDN, I mean SDN based on OpenFlow. It's quite important. So, separation between data plane and control plane. So no way to edit control plane. Centralization of the SDN controller allow us to have a centralized vision. No layer by layer header space analysis. Full access control with SDN controller. So it's generically in SDN environment we avoid all these drawbacks which I just listed previously on a previous slide, which belong to traditional network. So, considering SDN for security, I will consider network infrastructure, first of all, what kind of problem we can face it, or what kind of solution we can get in physical infrastructure, software stack, and network protocols. So, when we talk about the physical access to the network device, this is a big problem. Actually, nobody can guarantee that the router which you get from the box is really original, and there is no some special functionality within this router. So this is a big issue. So how we can make authentication of the physical equipment which our controller manage during the operation? Well, if we will use some static keys, so like SSL approach, in order to manage this problem for n routers, 7 routers, we have to have 7 sub-2 keys, so 49 keys. If we will increase the number of routers, the problems increase dramatically. So it's a huge headache for the security. So if we look at the SDN, so the problem sounds very, very attractively, because we have a controller. So controller can distribute the keys, and for n routers we will have an n keys, so the problems became much easier. Virtualization. From the point of view of network security, networking for me sound like separation. And again, in virtualization we have two kinds of separation. It's a logical separation when two virtualized entity share the same physical resources, or it's completely prohibited. And it should be a complete isolated, using different physical resources. It's just a well-known example from the time of Professor Corbata of a well-known MIT project, when it was the first time in the 60s when the people clearly set up the informational security program within a multi-programming operating system. How to be sure that when your virtual page will map it on a physical one, you cannot collect the information about the program which ran previously on the same physical page. It's exactly what I am talking about right now. Now, if we talk about the software issues in SDN, one of the interesting problems for me is what kind of services we should place in a control plane on a controller, and what kind of services we should keep in a data plane. So I spend a lot of time thinking, are there any services which look like should be placed in a control plane? But I cannot do this because I will violate this separation between control plane and data plane. Finally, I got it. SNMP. Well known as SNMP protocol. So it could be very logically placed as an SNMP server on a control plane, on a controller, like a controller application. But it's impossible, because in this case I have to push the whole package to the control plane with the payload. And this is a big danger for the security. Another good example, for example, if I would like to manage quality of service, and I would like to manage the bandwidth of the channel which I would like to have. So I should find some way how I can explain to the application in a control plane which manage roles, what kind of roles do I need? What the quality of these roles should be. So how I can bring this information to the control plane? It's a problem. Another good issues in this area is SDN controller architecture and organizations. So here I just listed some problems. Later on will be the special presentation dedicated to the controller, which was implemented in our Applied Research Center. So, first of all, controller should be placed in a trusted environment and be a trusted environment for C application. In order to be trusted, to be able to run in a trusted environment, we have to solve the problem how we can manage our physical resources, how we can trust our routers. So, what does it mean? That centralizing decision-making point, the controller should need to be closely monitored. It's a very important point, because when we talk about the accounting means it's a basis for monitoring. What kind of, how multi-dimensions I can monitor my objects. C applications and managed devices should be trusted entities. There should be a way to make sure that the controller are doing exactly what the administrator actually wants them to do. And when an incident happens, the administrator must be able to determine what it was, recover, and report the incident. So this is the requirements to the SDN controller, which we have to implement in any case in order to make it secure. Controller should be scalable. Let me turn back to the first presentation today about DDoS. So, and finally, controller should be high available. So what does it mean? It means in any case, if one if one instance of the controller shut down, in any case should be some other which will take the control on the same set of the switches. So a special interesting area is what's today mentioned many times, SDX. So if SDX, it's a SDN point with its own controller, and some application of this controller, just some way in band or out band, it's we will talk a little bit later, not during this presentation because I don't have enough time for that. If we will get the local forwarding policies from the domain, this application should develop the, let me say, multi-domain forwarding policy in order to stitching these different SDN domains. And here listed the mostly interesting actions, functions, which should be, from my point of view, implemented in SDX. So, support services for specific peering, direction to middle box, I mean VNF, virtual network functions, traffic offloading, inbound traffic engineering, drop the flows which don't correspond to intra-domain routing policy, block DDoS traffics, etc. So we can continue this list. And in terms of, it's again my interpretation, in terms of my presentation, SDX, it's a point, it's a border of federation. So here, the federates should negotiate their policy, and based on this negotiation, develop their mutual policy. This I will. So let me come to the main point of my presentation. So, open flow protocol security. How secure this protocol is from the point of view which I just talked about. So, from the point of view of authentication, what specification 1.4 proposed to us to use SSL? Actually, if we look at the implementation of open flow switches right now, because SSL solution is not so, let me say, elegant, so effective and simple, many vendors just turn on this solution, and you can use it. But this is, from my point of view, this is really a very heavy solution. From the point of view of authorization, it means that we have to be able to check that action, saying action, I mean when we download the rules, actions for switches, we have to be able to control that these rules are applicable to the specific switch. So we have to verify the set of switches, the set of rules which we try to download to the switch. And accounting, which means monitoring, which I already mentioned. And if we look at the specification of 1.4, we will find that the specification just describe 40 counts, and only 8 of them is mandatory, the rest just optional. But what is mostly important from my point of view, the semantics, the algorithm, how these counts, the value of these counts will be calculated, just prescribed. I cannot change anything. And this is from my point of view. And if we look at the traditional switches and routers, we will find millions of counts. And we can change the program, how these counts can be worked. So, the interesting example of a possible solution for authentication will be off-the-record protocol. This protocol was proposed in 2009, and the idea of this protocol is to develop so-called chat rooms. So every server with the switches under its control, developed, organize the chat room. And only the member of chat rooms can negotiate, can communicate, send a message to each other. And there is a special technique in order to be able to do this. Because, because in OpenFlow, the switch can be under the control of the different controllers who have to be able to develop several chat rooms. And also, if we are doing distributed controller, excuse me, I don't know why, but it's okay. So, over-the-record protocol, which was proposed by Borisov, Goldberg, and Brewer in 2009, and this is the main traits of this protocol. So it supports confidentiality, entity authentication, origin authentication. Origin authentication, it means that every time you can be sure what is the source of the message which you got. And also, what is also very important, that origin authentication allow you, if you are a member of the different chat rooms, and some of your neighbor also a member of the different chat rooms, you have to recognize what the message was sent by your neighbor and from what chat rooms, because from the security point of view, it's very important. So, if you are deals with the distributed controller, you will organize the next level chat rooms where only controllers will make a chat. So, as we can see, SDN natively solves many security problems, but nevertheless, OpenFlow as a protocol, as a control protocol, require a lot of security improvements. That's all. Thank you.
They detected a minefield of questions.
Ruslan, when you mentioned that SDN is nice because you have global state, it doesn't come for free. The fact that you have global state, you said SDN is nice because we have global state, so we can have efficient control, but it doesn't come for free. Global state. And usually global state, whether you import these on a single server is a point of failure. So then you have to go into other mechanisms. So it's very simple to say we have global state so we can control everything. It's overstated.
First of all, from my point of view, within one domain, we really can get effectively the global vision of the domain state. And definitely nothing free of charge in this world. You have to pay for that. But the price and what you get for this price is really valuable, because you can do a lot of, for example, if you one of the approach for quality of service management, well-known approach is multipath protocols. If you don't have a control vision of the state of your network, your multipath would be not so effective because no one can guarantee that the new roles which you will initiate will not cross each other. In this case, you will get on a person who bootlegs. So it will not improve the throughput of maybe I missed something in the question.
When you say global state, yeah, in a small scale,
I mean domain.
You have to be very careful with this because, again, making sure that you have consistency on policies if it's a global scale is really an issue. It's as complex as before.
You agree?
Any other questions? I've got a quick question. You had up there your hierarchical controllers in the last few slides in the intra-domain. But I didn't see in those last slides on the intra-domain about authorization. There's a lot about authentication. But how do you, in a hierarchical controller and control structure like that, how do you do the authorization properly so that you're not getting different applications trying to share the same flow spaces?
First of all, we have to be able to do authorization the controller of the different domains between each other. And through this authorization, we can authorize the application.
Yeah, I still see some problems there because this doesn't really. I'm a proponent of the virtualization space. We provide a single flow space for a user across all their.
If you're talking about virtualization in a data plane, and in this case, from my point of view, SDN can improve only by means of NFV, the security solution.